So I've had several questions about the right-hand rule, and some of you wanted to see a little bit more, a few more examples of using the right-hand rule. Right-hand rule. So there's several places we use it in magnetism. The first rule of using the right-hand rule is use your right hand. If you've had a lot of trouble with it, there's a chance you're using your left hand. So, right, do this. The one that makes an L is your left hand. There's your right hand. That's probably not your problem. We use the right-hand rule. The more difficult time we use it is to get a cross product, to get the direction of a cross product. And the first one we came across was F equals Q V cross B. So we have a charged particle moving in a B field, and the force due to the B field is not along the B field like with an electric field, but it is V cross B. So to do it, you just need to have, let's do some examples. Say for instance you have a B field going out of the board. These little dots represent the B sticking out. And you have a velocity, say up, say your particle of charge Q is going up, and it experiences a B field this way, then V cross B, you take your fingers and put them along V, because V comes first. And really your fingers could go any way along V. They could go this way, they could go this way along V, this way, any way. But then you have to go with B. So when you turn your fingers like that, they have to point along B. So if all the way your fingers could go along B, they have to go this way, because B is sticking out. And so V, now when we turn our fingers this way, now they point along B. V cross B. And then there's only one orientation that will do that. If I turn it this way, it's going against B. If I turn it this way, it's going 90 degrees to B. If I turn it this way, it's V, and the fingers point to B. And in that case, the thumb points to the right, and the force is that way. We could do the opposite. We could do, say, the B field is into the board, and V, the charge, is again going up. Which way is the force? Again, the fingers go along V first, because it comes first in the cross product, and they can go any way you want, but they need to go, or when you bend your fingers, they go along B into the board. And when you do that, the force is this way. And then, sort of, I guess, the final case, what if this thing were going up, and the B field was in a uniform B field that way? Again, fingers go up, they could go any direction, but you've got to put your hand in the direction where when you curl your fingers, they move towards B. And that's only this way, and then your thumb is into the board. So here, F is into the board. And you do this for any vectors, any cross product, A cross B equals C. This is how it works. So it's always fingers along the first vector, turn them towards the second vector, and wherever that leaves your thumb is the direction of C. So the same method applies to F equals IL cross B, which is almost the same thing. You just have a current going in a direction L cross B. And for instance, the torque. Let's do a torque real quick. All right, so torque was IA cross B. So torque was IA cross B. So you have a current loop with some area vector A, and B is this way. Well, it's the exact same thing, even though it's different expression. It's A crossed with B, it's into the board. So the torque is going into the board here. There's another way to do it, though. If you don't like all this spinning your fingers around, there's another way to do it. And that is, let's erase this again. That is not to do the right hand rule that way. You still use your right hand, but you do our little salute here. You make your gun and then point up your middle finger like that. And then, instead of having to actually curl your fingers, you just remember which finger is which vector. You basically say, the first vector you think about, V is your thumb, Second vector you think about, B is your, what is that? I think that's your pointer finger. And then F is tall man here, right? So if you can just always remember it's V, B, F, then you can do these same problems without having to move your hand in some strange way. So if we have V up here, and I think what we had, say at the time that we had V into the board, then you just have to rotate your hand to where V is up, and thumb along V, pointing finger along V, and then you instantly know F is going to be this way. And you could even do this, which I've done as an example for you here. You could even write on your fingernails, put V on your thumb, and B on your pointing finger, and F here. And then you can actually sit here and look and make absolutely sure you have V and B in the right direction. And we'll even allow that within the honor code. So we won't consider this cheating if you want to write that on your fingernails. If you tattoo it on the pads of your fingers, I'll give you a bonus 10 points at the end of the semester. Let's see. There's another use of the right-hand rule. So this is for the cross products, and it's the same no matter what kind of problem it is. It's always A cross B is C. Another use is that any time we have something curling around, and we have to think of it as a vector in the plane normal to the area made by the ring, we always define that by the right-hand rule. For instance, if you have a current loop that has some area, and you need the area vector, do you make the area vector up, or do you make it down? Well, basically, you define a direction that you call just the positive direction. So in this case, as you put your fingers around the positive direction, your thumb goes up in the direction of the vector. Okay, so here this is sort of in 3D here. So this is curling into the board like that. The thumb is A. Another example is when we had the current on a wire, or if we had a wire carrying current I this way, and we want to know the B field. Remember, the B field circulates around the wire. Which way does it circulate? Well, you put your thumb along the vector I, and the B field circulates with your fingers. So all the equations are set up that this will always work out correctly if you do it by the right-hand rule. They have all the negatives and positives in the right place. Another one is if something gets pushed around, say this ring gets a torque pushing it around that way, then we would say if the force is pushing it around that way, then the torque ends up being that way. But again, sometimes you can use sort of the right-hand rule like that. So those are actually distinct uses of the right-hand rule. For this kind of use, just always remember it's always the case that if you can imagine where you need to curl around and use your thumb to figure out a direction, always just make your fingers do the part that's curling and your thumb do the part that's straight. Okay, good luck.